Today we're going to talk about spelling correction. Lots of applications make use of spelling correction. For example, word processing. Almost any modern word processor will take a misspelled word like component with an A and give you suggestions like component with an E and automatically replace it for you. Modern search engines will not only flag an error, so language spelled without a U here, but give you the results as if you had spelled the word correctly. And modern phones, additionally, will automatically find misspelled words. Here I typed L-A-Y-R, and it replaced it automatically, or suggests a replacement with late. We can distinguish a number of separate tasks in spelling correction. One is the detection of the error itself, and then the correction of the error once you've found it. And we can think about different kinds of correction. We might automatically correct an error if we're positive that the error, that we know the right answer for the error. So HTE is a very common misspelling for the, and so many word processors automatically correct HTE. We might suggest a single correction if there's only one very likely correction, or we might suggest a whole list of corrections and let the user pick from among them. We distinguish two different classes of spelling errors. Non-word errors are errors in which what the user types is not a word of English. So G-R-A-F-F-E, a misspelling, let's say, for giraffe, is not a word of English. By contrast, real word errors are errors in which the resulting misspelling is actually a word of English, and that makes them somewhat harder to detect. And we can break up real word errors into ones produced by really typographical processes. The user meant to type 3 and typed there, let's say. Or cognitive errors where the user meant to type a word like peace and instead typed a homophone of the word, or TOO instead of TWO. And in both cases, what's produced is a real word of English, but by modeling the differences between these kind of errors, we might come up with better ways of fixing them both. How common are spelling errors? Depends a lot on the task. So in web queries, spelling errors are extremely common. So practically 1 in 4 words in a web query are likely to be misspelled. In word processing tasks or on phones, it's much harder to get an accurate number. So there's been a number of studies, and most of these studies are done by retyping. You give the user a passage to type, and then you measure how well they type it. And of course, that's not quite the same as users naturally writing messages or typing. Nonetheless, if you ask users to retype and you don't let them use the backspace key, they make about 13% of the words. 13% of the words are in error. So indicating that a lot of words, they correct themselves with the backspace. If you let them correct, now we're turning to an experiment on a PDA style of foam-sized organizer, they'll correct about 7% of the words themselves. They'll still leave about 2% of the words uncorrected on an organizer, and similar numbers on people doing retyping on a regular keyboard. So a number of about 2% were people typing, and probably a much higher number for web queries, and probably a much higher number for people texting, are the kinds of spelling error rates that we see. How do we detect non-word spelling errors? The traditional way is just to use a large dictionary. Any word not in the dictionary is an error. And the larger the dictionary, it turns out, the better this works. For correcting these non-word spelling errors, we generate a set of candidates, that's real words that are similar to the error, and then we pick whichever one is best. And we'll talk about the noisy channel probability model of how to do that. And it's also related to another method called the shortest weighted error distance method. So we find words that are not in the dictionary. For each one, we generate a set of candidates. And those are going to be real words that are similar. And we'll talk about what similar means to that error. And then we'll pick the best one. For real word spelling errors, the algorithm is quite similar. Again, for each word, we generate a candidate set, but now we do this for every word in the sentence, not just the words that are not in some dictionary. So in real word spelling error correction, we don't use a dictionary because, of course, the errors are in a dictionary, so that wouldn't help. So for every word, we generate a candidate set. So we might find candidate words with similar pronunciations, we might find candidate words with similar spelling, and depending on the algorithm exactly, And it's very important that we're going to include the word itself in the candidate set, because the every word might be a misspelling of some other real word, or it might be the correct word. In fact, most words are probably correct. So for each candidate set of each possible error, we're going to include the word itself. And most of the time, in fact, we're going to pick that. And again, how we pick the words, we might use the noisy channel model. We might use a classifier. We'll talk about that. So we'll discuss the different methods of detecting these errors and correcting them in the next section.